Welcome back to Checkpoint Jumpstart Maestro training. And in this section, we're going to look at some command line commands on both the Orchestrator appliance as well as the single management object of security groups to examine what can you do for diagnostic, troubleshooting, or monitoring in the command line. It may be that you need to restart the Orchestrator service itself. I'm going to time how long that takes. The command is orchd space restart. And off we go. So working on shutting down the Orchestrator service. Done. Now starting the Orchestrator service. I'd point out that currently in this demo environment, there are two orchestrators. So they're doing active-active. I shut down one. So as long as things were properly redundantly cabled, then there should have been no traffic outage. But it's also possible that I may have made a configuration change to the other orchestrator while the orchestrator service on this appliance was down. So it will check to see if there have been any changes to the configuration files. And as it turns out, there hasn't, but good thing to check. And there you go, a little bit under a minute and a half for a fairly unloaded orchestrator. Clear screen, and there's some other commands that I just want to demonstrate quickly. The orc_info command does a pretty comprehensive diagnostic dump of log files and config files and other interesting things. So you would do this and upload it as part of a service request. It's very helpful for assisting. So you would definitely want to do an orc_info again on the orchestrator. And then what you get is a gzip tar file. So there's a magic incantation which will list the contents. And it's going to be a long list, so I'm going to type it through a paginator. So yes, log files, a lot of log files, config files, and the output of some commands that were run, stored to the temp directory so that they would be included in this. Next, there's a config file that was included in that. In /etc, the sgdb.json file. And this has the configuration of all security groups on the orchestrator appliance. So the appliances, the security gateway modules that are assigned to security groups, how many security groups there are, uplink ports assigned to the security group. So I have currently 2 security groups defined. And this is the second one. Note in the middle of the screen there, it's a VSX Security Group. This file also exists on the single management object in all of the security gateway modules in a security group, but only has the contents relevant to that security group and doesn't list any data about other security groups. Another useful command And I'm going to paginate this because it may just take up most of my screen. So this command here is dumping the state of the physical ports on the orchestrator. So which ports have something cabled in, which ports don't, etc. And useful to get just a quick picture of the settings for the ports on the orchestrator. Another command, LLDPCTL, for link layer discovery protocol. I'll paginate this. This prints the information that was discovered via LLDP. So we can see that there's another orchestrator out there. There are some security gateway modules. And right now there's only 2 security gateway modules displayed because of an issue in the lab where the demo environment is hosted. Normally you would have way more than that. But this will give you, for instance, this is one way to get the serial number of the security gateways. Next, I'm going to show you the member command. You can abbreviate it. I'm a lazy typist, so you can abbreviate it M. This allows you to secure shell from the orchestrator into any security group, any security gateway module that's up. And I guess I'll do that. So now I am connecting to the single management object because it's security gateway module 1 by default is the single management object of the first security group. So that's what the first one means, is security group 1. The second one means member 1. And note the IP address it displays here, 198.51.101. This is an internal network that is maintained, that is built between the orchestrator and all security gateway modules. You can ignore the diagnostics message. They said there's an issue in the lab. So you need to be in expert mode for this command. Now I'm in a security group. Here I can't move to a different security group. I can only move to a different security gateway module. So I'm going to do that. Now I'm on security gateway module 2. And here in security gateway module 2 of security group 1, there is a copy of this sgdb.json file, but it only lists information about this security group. So the other security group, VSX Security Group, Security Group 2, is not displayed here. So next, I want to show you some more commands on the single management object. Another useful command, ASG, on a single management object has many options. One of them, ASG monitor, will put up a constantly updated display. By default, it refreshes every second. You can change that by specifying a different interval. But this is showing the status of this security group and the security gateway modules that are in it. So there are 2 security gateway modules assigned to this security group, and it is currently happy. The security gateway modules are active. Get out of this command, I usually use Control-C. And a slight variant of this command, I'll show you the help. There's various options. For instance, you can list virtual systems if you're in a VSX security group. But the -V option gives you a little bit different information. Here it shows the health of various components And over on the right, there's a wait value, which you can modify that. But for instance, if a security gateway module were down, 1 out of 2 were working, leaving 1 that's down, then the weight of a security gateway module, which is 6, would be absent. So right now, everything is healthy. And if you multiply everything by its weights and add all of that together, you come to 56. That's the maximum possible weight when everything is working. And if one of the security gateway modules was down, then we would lose 6 points and we would be at 50 over 56. And that's useful for some advanced configuration, multi-site deployment of Orchestrator. ASG stat command gives you information about, again, the security group, just in a slightly different format. There are 2 security gateway modules that are currently happy. Switch back to not full screen mode. For this next command, ASG debug verify, I find it to be very useful. This command runs several diagnostics on the orchestrator and on the security group, and it provides concise summary of the result of each of those diagnostics. See that some are failing. This is for various reasons, such as I've not yet installed policy security group. Also, my demo environment is having a bit of issue. This command is typically followed by the ASG debug list command for more information. The DXL calc command is useful for visualizing distribution modes. And so recall that distribution modes determine which security gateway module should handle the traffic for a given connection. And the default is general, where both the source and destination IP address, and by default, layer 4 ports are also considered. So source IP address and port, destination IP address and port are all used in the algorithm to determine which security gateway module should handle the traffic for this connection. Another option is user distribution mode, which uses the source port and destination IP, or network distribution, which uses the destination port and source IP. We'll look a little bit more into the distribution modes coming up. Another useful ASG command. This shows you key performance indicators. So note the load averages that are displayed for both Core Excel cores and Secure Excel, or Secure Network Distributor cores. And this is a very small deployment with no policy, no traffic, so this isn't very interesting, but this command automatically updates and is useful in a production system. Next, really quickly, I wanted to show the diag list command. It provides all sorts of tests that can be done. So You use ASG diag print and the test number, and it will conduct that test. This is just a handy cheat sheet, so you don't have to remember the numbers. So ASG diag command is very useful for running system diagnostics. So earlier we talked about distribution modes. Distribution modes set the algorithm which determines which security gateway module should handle the traffic for a given connection. It does that by looking at either the source or destination IP address, depending on the mode chosen, and source or destination port, depending on if layer 4 is enabled as part of the decision process. And so the default distribution mode is general, which uses both the source and destination IP addresses and source and destination ports for the decision. There's also user distribution mode, which uses the destination IP address and source port. There's the network distribution mode, which uses the source IP and the destination port. And there's also a topology, auto topology mode, which uses the information from the single management object security gateway object that was created in Smart Dashboard, or sorry, Smart Console with topology, indicating which interfaces are internal, which interfaces are external. It uses that. So you can see the current distribution, and you need to be in the global CLI shell, which I was in expert mode. I exited out of that back into the global CLI shell. And right now the distribution mode is general, and you can change that. You can show on a per interface basis. Also see the status of the distribution mode. Earlier we talked a little bit about the correction layer. And again, the job of the correction layer is to handle NATed traffic, because the distribution mode algorithm uses source and or destination IP, source and or destination port to determine for this packet which security gateway module should be handling the traffic for this connection. And with NAT, you're changing either the source and or the destination IP address and possibly source and or destination port. So the distribution mode algorithm will pick the wrong security gateway module. The correction layer exists to forward the traffic that was handed off to this second security gateway module back to the original security gateway module, which was handling the unnatted traffic, so it sees all of the traffic, which is necessary with stateful inspection. You can see some correction layer statistics. Again, in this demonstration environment, there's really no traffic, and I certainly haven't turned on NAT, so the correction layer hasn't had to do anything so far. So some best practices. I mean, it depends on the specific network mix of the deployment site, but generally distribution mode using both source and destination IP, source and destination port, will do the most granular distribution of connections to the security gateway modules in the security group. However, if you're using NAT, then to simplify the job of the correction layer, Any hide-natted networks set them to use user mode. So we're looking at the destination IP and source port. And the destination networks, if for instance static NAT, you would use network mode, which uses the source IP and the destination port in the distribution algorithm. The global CLI shell is very convenient in a security group because the configuration changes that you make in global CLI shell are automatically propagated to the other security gateway modules in the security group. But in expert mode, there are a number of command line global commands that begin with G underscore. So one G underscore command that's useful, G underscore update conf file. And so this command wants the path to a config file and a var equals value pair, though if you leave off the value, it'll just remove that var from the config file. So you obviously don't want to do this unless you have a very good reason to be editing a config file. But for an example, this fw kern config file, I'm going to change the ARP forwarding setting. Rather than risk typoing it, copy, paste. And you can see that the value's been changed in the config file on this security gateway module. You can ignore that failed system diagnostics background issue. You can see that the value's been changed here as well. I'm going to go ahead and put it back. You can see that it's been changed on the second security gateway module in the security group. Going back to the first security gateway module, you can see it's been changed back. So useful command if you need to update some config file parameter on all of the security gateway modules in your security group. Another useful command is a global TCP dump command. So same syntax as TCP dump. It will aggregate all of the packet capture data and very useful for getting a large amount of packet capture data fairly quickly. You probably want to use capture filters. Generically, the G all command will run whatever command you give it as an argument. It will run that on all of the security gateway modules. So come up with a command, might possibly someday be useful. Show me the tail end of this same config file, fwkern.conf. And it's only 2 lines in that file, so it wasn't a hard thing for tail to do, but it ran it on all of the security gateway modules in the security group and then showed the output by security gateway module here. If you have a security group defined, you automatically get active backup clustering. There will be one security gateway module that is designated active, and then one that is designated backup in the same security group. So what happens with packets? The orchestrator receives a packet from an uplink interface. It uses the distribution mode algorithm to calculate which port, downlink port, that connection should be handled by, and the algorithm guarantees it will always be a downlink port that security gateway module is plugged into. So it'll calculate that it needs to go out this port. It'll switch the packet out that port. It'll be received by the security gateway module. And that security gateway module, if this is a new connection, will calculate which other security gateway module in the security group should be backup and start doing state synchronization to that security gateway module. And that's done over the synchronization VLAN. So you have the active that's processing the traffic for the connection and the backup that's being synchronized so it has up-to-date state tables such as connections table information. And so because there's only 2 security gateway modules that are participating in the clustering, you don't have the extra overhead that the general products cluster Excel experiences. The Maestro, I guess, version of clustering, they call it Hypersync, limits the overhead, and so there's a performance penalty of about 1% of throughput per security gateway module in the security group. So if you have 4 security gateway modules in the security group, then you are getting roughly 96% of the aggregate throughput capability of those 4 security gateway modules. There's some overhead. And this is much, much better than cluster Excel load sharing, where in my experience, when you get to maybe 5 active load sharing gateways in the cluster, adding any more makes it worse because of all the overhead of synchronizing everybody to everybody. By limiting the synchronization to be between the active and the backup, that really eliminates a lot of the overhead of the synchronization. And again, it's about 1% penalty. So that wraps up the command line and the little bit of troubleshooting that I wanted to show you. Thank you very much for attending this Jumpstart training on the Maestro Hyperscale network security solution.